Hello there, this is Toby, and welcome to the show where we code a programming language live. Even though this one won't be live, I'm gonna be recording this and then uploading it later. Okay, so today what I want to do is implement a proper if statement. We kind of already have a way of using if statements. Basically, we said that the if statement was gonna not even be a special statement. We said there's gonna be an if function which can take the conditional value and then two code blocks. And code blocks in this language looks like this, right? And it's basically gonna be it's a functional approach to doing if statements. Now, so given that we have this if construct, why am I implementing if statements? Well, because one, this doesn't look terribly great. We don't have an else word in this picture, so it's not totally, it's a little bit unconventional. And also another big reason why I want to implement the if statement properly is because if you're going to be building a programming language yourself, then chances are you might implement an if statement properly. So I want to do that on stream so that I provide an example of doing that. So I think what I'm going to do is, in addition to allowing this way of calling an if statement, we'll also have a sort of native way of doing if statements, or maybe we won't. Maybe we'll take away the native way. So I'm gonna convert this if statement example to another if statement. I'll call it example if 2. I am gonna double check my recording software. Make sure my mic is working, because you never know. Okay, it does seem to be working, and I am recording. Okay. All right, so I'm going to do an if statement that kind of looks like this. Like that. I think that's reasonable. Oh, we want to close. I think this is reasonable. So first we'll write a parser for this version of the if statement, and then we'll write the generator to go along with it. One possibility is where we might have, so if statement is actually a very common example in the textbook. In the textbook, where this is a place you can potentially run into ambiguous grammar territory. As in, there could potentially be two different ways to parse the same thing. So I'm gonna check my grammar for that, and the place where usually an ambiguous grammar can come into play is if you have a nested if statement like this. So if you have an else if greater than maybe like greater than 21, then else if it's greater than 18, and then an else. Like you can have a beer, and then at 18 is like you can have a root beer maybe, and and then else you can have a glass of water. How about that? Oh, you can okay, that's an interesting eval, but whatever. Maybe this is like 13 you can have a root beer. So the question, like, because this guy here is a valid if statement, I think the ambiguity comes let me look at this. I'm sure I understand this case for ambiguity first. I think the ambiguity comes when you don't have blocks, maybe. So if you don't even have blocks, then it's unclear whether this if statement should be grouped within the else block of the outer if statement. So like whether it should be structured as this, or whether it should be parsed instead like instead like this, I think. Is that right? Is this right? Yeah, if you have an else if construct, although either way it works, doesn't it? I'm actually what's another way to parse this statement? Is there another way to parse this statement? So I'm gonna Google it. Grammar ambiguous if statement. Maybe in a Wikipedia article or something. Elimination of dangling else. I think that's what it is. So let me read this to refresh my memory. So if A then S, if B then S, 1. If A then, if B then, oh, okay. It's actually like this. So, which I don't have this case. So if A then if B, then S, else. You don't know which of the if statements the else belongs to. So in my syntax, I guess I would write it like if greater than n21, then if greater than this, let's do 42, then print you are old, else print you are still an adult. Still an adult, does that make sense? So it's not clear whether this else belongs to the first if statement or the second if statement. If we had blocks though, that would not be an issue at all. Because if we just force the user to use blocks, then that would completely not be an issue at all. So that's something. Which I actually have been doing anyway in each of the programming languages I've been making. I kind of force users to put in blocks. So for that reason, I've never concerned myself with this particular problem. But I think what I want to do here is intentionally hit this grammatic ambiguity to demonstrate it, and then we'll fix it perhaps by making blocks mandatory. Yeah. Okay. So let's do this. Okay. So first let's make the grammar. So this is a bit of a mess right now. I have a lot of examples that I'm not even intending to make it properly into the language. In any case, I'm gonna go to the grammar file, which is here, and add an if statement. So I'm gonna say an if statement is a one of the statements. And go to the bottom of the file and define the syntax for it. Let me look at my lexer. My lexer, I think this is fine. So mandatory white space after the word if, and then we're gonna have an expression. Do we have an expression? Yes, we do. So if we have an expression, and then some mandatory white space, and then another expression. So this is from here to here, that's the mandatory white space. We might want to allow for multi-line mandatory white space though, which at the moment we are not doing that. So I think what I'm gonna do is make a new symbol that means multi-line white space. And it should consist of a multi-line white space character or a multi-line white space character and then more multi-line white space, okay? Where a multi-line white space character is either a mandatory white space or a new line, which let me make sure I have a new line accounted for. I do not. Oh, no, there it is. Okay. It's called new line, all spelled out. Okay, so I believe with this, I can have a multi-line white space, which is mandatory. Yes. And then I'm gonna say, well, an if statement is an expression and then a multi-line white space, then another, not another expression, and then yeah, actually, yes, actually another expression, which could potentially be a block expression, but it could also just be a regular. Could it be a statement? Let me see. We have expressions and statements. An expression can be a code block and a function call. And then we have a statement, which could be assignments, function calls, function definitions, and if statements. We need if statements to be expressions, actually. Wait, is that true or not? Actually, no, I'm not gonna do it that way. I'm gonna say this is a statement. Okay, I'm gonna say if there's an expression for the conditional, and then we have another statement, and then else. Come on, I'm just gonna drag this over here. And then we're gonna have an else, and I guess after the statement, after the statement, we could have multi-line white space and then an else, and then that could be another statement, I suppose. And that's the end of the if statement, I think. Does this work? I'm gonna just test this to see if it works. I guess I should say that probably, well, let's just try this. I think it might work. Undefined symbol new line is used. That's because it's a token coming from the tokenizer. So if I mean to use a token coming from the tokenizer, I need to prepend it with the %sign. And I forgot about that. Okay, so now let's see. I'm gonna try to have this guy parse. So let me just have this be the example here. So if n is greater than 21, then if n is greater than 42, you're old. And in this case, it's actually not clear which if the else belongs to, and that's the dangling else problem. So I think we should meet this problem. I'm gonna parse this example if to unexpected n of file. Oh, that's to say that didn't successfully parse the if statement, I think. So we could use nearly test to test this. So I think with nearly test, I have to give it the name of my grammar file and then test some input. And because I have my input in the file, I'm gonna take my input. Yeah, it wants me to, I could paste in the input. That's another way to do it. I'm gonna use the cat command to read out this file and then pipe the input into the nearly test command, and now it shows me the parse table. So I can hopefully, if I can understand what this is saying, then I can hopefully debug this situation. Let's see what's going on. So at this moment, it is in the middle of parsing this if statement. So that's good. In fact, it has finished parsing the if statement. The dot is all the way at the end here. And which begs the question, why did not this succeed? So after, so it succeeded for this statement. It succeeded in reading this statement. Do we need something else to complete a statement? Because a statement is part of a statement which is part of a program. So I would have thought after successfully parsing a statement, then it would have successfully parsed a statement. Oh. Wait. I don't get this. So this is parse of this statement symbol started at chart 16. So let's scroll back to look for chart 16. So we're at chart 16. So from chart 16 is the line that started this statement. So this is the rule that started the rule that ultimately completed the if statement here, because we know it's completed because the dot is at the end of the rule. Okay, now let's go back to chart 16. So due to that, it should have completed the statement, and it should have, for each rule that ends with statement in this table, it should have moved the dot over. However, the problem is we don't have any rule in here that is waiting for a statement for some reason, and I don't actually know why. So this statement was initiated from 16, which is the same rule, I mean the same chart as here. But where is that? Oh, it's here. Oh, okay. I see. Oh, but the else. Oh, I see. Huh. Okay. We're parsing this. We're the else clause needs to be optional. That's the problem. We did not allow for the else clause to be optional. And so let's go ahead and allow the else clause to be optional. So, okay. So I'm going to put this whole thing, the else clause, including the white space before it, allow that to be optional. I think I can do it like this. So let's reparse the parser. That did it, and parse it, and now this time it completed. Great. Okay. So I'll do it this time using this command line, and I guess what I want to do now is, do I print out the AST as a file after I do that? I am supposed to do that. Oh, I bet it hit this part. Yes, the parse tree generates multiple results. Okay, perfect. So that is what I expected. The parse tree should generate multiple results, and we'll actually look at. Actually, I think it would be helpful, this investigation, to whenever it generates multiple results, we're gonna spit out the JSON files for each of the results. So let's go ahead and do that. I'm gonna actually do this same code here, but for each result, of the parser.results, because there are multiple of them, we're gonna grab the AST based on the index, and then the AST file name is actually going to, we're gonna append the index to the end of the file name. There, and then it will write that out. Okay, so let's do that. So now that length. So now, yeah, it wrote out both of the parse trees into AST files. So let's take a look at them. So we'll look at them left and right. Okay. So on the left is version 0, and I believe on the right, oh, still version 0. Okay, now on the right is version 1. Okay, so we'll go look through them and see where the difference is. Oh, one problem. Oh, one problem. I actually pause. Need to go back. I forgot to write the AST converter for this statement. So let me go ahead and do that. So I'm gonna write an AST converter that takes all of these symbols that were matched as an array and return an object. I'm gonna call this object type if statement, and it's gonna have a conditional, which is that guy, which is at index 2. And then it has a consequent block, which is at index 0, 1, 2, 3, 4. So index 4, and then the alternate could come. So alternate block of the code could come at, this is index 4, so this is index 5. However, because the meat of what we want is actually within here, so this would have been index 0, 1, 2, 3 of index 5. However, if I did this, it wouldn't work because there's a chance that data index 5 is non-existent. So I'll use this guard clause to protect against that situation. This says if this is non-existent, then don't bother calculating that one and just return undefined. But if data index 5, which is that guy, does exist, then go in there and grab that guy. So that's what it's saying. Let me regenerate the parser. Gen parser. Now parse it again. Again, it generated 2 versions of the file, and hopefully this time it actually says if statement. Yes, exactly. So now let's look at these 2 versions of the if statement side by side. In the first version on the left says we have a conditional that shouldn't be different, that part. And then this, so on the left hand side, the consequent block has another if statement in it. On the right hand side, it also does. Okay, that actually does make sense. And then within the conditional of the nested if statement, so this is the outer if statement, this is the inner if statement, there's a conditional. Oh, maybe I should look at the code. Okay, and have this code, we're gonna have this 3-panel situation. Does this work? We shall see. Okay, so the conditional on the inner if statement is whether greater than, is a function call is whether n is greater than 42. So yep, so that makes sense. That is also the case for this conditional, greater than n 42. And I think the difference will come in the next part, which is that the consequent of the nested if statement in the first version, let's see, is a function called to printing out you are old. the alternate is null, whereas for the second version, the consequent is printing out you're too old, but then the alternate is printing out you're still an adult. Whereas in the first version, the alternate is null, and then the alternate of the outer if statement is the printing out you're still an adult. So in the version in the middle here, it interpreted as the dangling else belongs to the outer if statement, but in the version on the right here, it interpreted as the dangling else belongs to the inner if statement. So we don't really want this situation going on, and the way I'm going to resolve it is kind of by force, which is to require that users use blocks with their if statement. So if they're forced to use blocks, they have to be explicit about which if statement the if statement belongs to, right? So they either have to do this, or they have to do this if we force them to use blocks. So that's what I'm gonna do, and the reason, and there might be some of you that are saying, well, but now you're requiring people to use blocks, and that's not so convenient. You know, what if they want to write less code? I guess my attitude towards that at this point is in my own code, when I'm writing JavaScript or TypeScript or C, I always force myself to use blocks anyway, because if you don't use blocks, there's actually a potential for a very, very bad kind of error that can happen. In particular, if you write code like this, there is actually a pretty good chance that somebody else will come in after you and try to add a statement right under your line, while believing that this statement also belongs to the same block. And this kind of error is something that has caused the heartbleed bug in the SSL library a few years ago. So it's actually a problem, and so one of the recommendations that I got when I was reading a blog post by Isaac Schluter, I believe, the founder of NPM, is that you know what, guys, just use blocks all the time. So since then, that's what I've been doing. So if I'm using blocks all the time, maybe it's not so big a deal that you just use blocks all the time, and you can still be productive writing code that way, while writing code that's a little more safe, perhaps. So anyway, that's what I'm gonna do. It's my programming language. I'm gonna make blocks mandatory on if statements. So, and what that means is, instead of letting that be just any old statement, I'm gonna want this guy to be a code block, which I think I have already written. Yes, I've written a symbol, a syntax element called the code block. I'm just gonna pop it right in there, and then in the else, there's also gonna be a code block. I think that'll probably do it. So once I do this, generate the parser again, parse it again, and now it's cool. I think I already changed my code to use a code block. Yeah, so code blocks are mandatory now. If you try to not use a code block like that, it will not parse. It just will not parse. You're forced to use code blocks, and that resolves the issue. Okay, so now I suppose what I want to do is to write the generator for this code. So let's go ahead and do that. So if I try to generate the code, all right, generate it one more time. If I try to generate the code, node.js generate example if2.x.est, It doesn't know how to generate code for an if statement, so let's fix that. And I guess I have a couple of choices here. I could have it generate an if statement in JavaScript, or I could have it generate a function like in the format of our previous if statement. I think I'm actually going to have it generate a if statement in JavaScript. This is a transpiler. So yeah, let's translate this guy to JavaScript. And in JavaScript, if statement would look something like if, and then parentheses. So let me get a conditional. Is this called generate? Yeah. I'm gonna generate the JavaScript code for the conditional. I'm gonna call this the longhand form. Call it conditional. Okay, so this is a JavaScript form for conditional. I'm popping it in this if statement, and then I'll have these curly brackets. And let me think here. I think I have a thing that handles code blocks already. However, at the moment, I am calling generate functions to convert a code block into a function. And I think I want a different thing in this case. So I'll say generate statement block. Generate, I'll call it generate block. Yeah, generate block. Given a node that is a code block. Yeah. I think so. Yeah, I think that's good enough. And this assume is this is gonna assume this is a code block, and a code block. Wait, what is a code block? A code block is a node that has type of code block, and then it's got statements in it. Okay, so I'm actually gonna steal this code here. So this piece of code wants a statement, so I grabbed it for that piece of code here, and then yeah, I actually don't need the return in my scenarios because I'm not generating for a function. So the body is just gonna be that simpler, and I'm gonna return. Do I have this indentation? Oh. This indented body code goes through every line, and the body splits it up and puts some indentation on it. I'm gonna extract this guy out into an indent function, and then just call it again. We'll just call this guy a string. Okay, so I'm gonna indent. Replace this with just indenting the body. Okay, now that I have a indented body, I'm gonna return it as this block. Okay, so I'm hoping this is gonna work for me. Generate block for node.consequent. that's not enough because I also have an else clause, but I wanna generate it first to see what would come out. Return equals, that's not right. Oh. Cannot read property map of undefined. So, statement is somehow undefined. So note that consequent. Did I misspell consequent? No, this is an if statement. It should have a consequent. Yeah, it's an if statement. It should have a consequent. The consequent should have a statement. Passing that in here. Statements. But it's saying it doesn't. On line 70, that's this line. Let me print this node out then. And have a look at what it is. It's a code block with statements. Oh. The consequent is actually a array of code blocks. I don't think that's right. I need to fix the parser. That's not what I want. So the consequent should be what does a code block return? A code block should return an object like this. So that doesn't make sense then. Huh. That doesn't really make sense to me. In each consequent, it's an array of a code block for some weird reason. I'm expecting it to just be the code block object. Where else is code block being used? Okay. I'm gonna print it out here inside the parser to try to debug this. Let's parse the thing. And in each case, where I printed out the code block, I'm getting an array of objects. Why is that happening? That doesn't make sense, because in a different place, in a place where I have an expression, let's say, let me just make a small example here. Code block dot x so this is a code block. I have to have a new line maybe? Yes, new line is mandatory. Okay, so in this one, the value is the value is also it's also an array of code blocks. So this is unexpected. I'm kind of wondering why it was working before now. It's this code block without parameters. I need a ID here to unbox this because I needed a converter and I can just use ID here. Yes, that's what the problem is. Probably a bug that was introduced after I did a refactoring. So I think this should be fixed now. Yes, it's fixed. Okay. All right, so back to what we were doing, which was if example 2. So let's reparse that one. Example if 2.x. Okay, so we get these code block objects that are actually code block objects now. Great, let me get rid of that console.log statement from the parser. That was there only for debugging purposes. Okay, so now we have this new AST. Let me get rid of the two different versions of the AST. And now we have the new AST where the consequent is just one code block object. So now the generate function should be happy about that. Let's just try to generate this file. So it generated example if 2.js. And it did this, and that looks pretty good, except that it doesn't have any else statements. So let's pop the else statement in there. There's an extra semicolon that we don't really need. It's okay, I guess. Not too big a problem. So let's grab the if statement. I mean the else statement. I'll say if note that alternate, which means there's an else statement. Else we can just return the if statement, I guess, if there's no else statement. But if there is an else statement, then let's generate an else statement. So the else statement should look like there's an else. Let's put a space before the else and then generate block again for node.alternate, and then return if statement plus else statement. I'm gonna take out the console.log I have in here, I think. Okay, now let's look at it. We have an else statement now. Great. There's these extra semicolons here. But I don't mind them too much, so I'm just gonna leave them there. And I think this code should work. Yeah, so we can actually run everything in one step. Example if 2.js. I mean not .js, .x. Run the whole thing from the beginning. You're still an adult. Okay. You are still an adult. If it is greater than 21, Is n greater than 21? No. And oh, you're still a child, probably is more apt. But if you are greater than 21, oh, I kind of meant to do this. Okay, so I'll do something like this then. 2 else. You are a young man or young adult. Young adult. Then if you're greater than 42, you're old. Otherwise, you're still a child. Let's see if that works. You're a young adult, 22. 14, you're still a child. And then if you're 50, you're old. Okay, that looks good. That looks like an if statement for me. So if we have this if statement, then we don't actually need the I have a runtime, I believe. We don't actually need to implement the if statement as a function anymore. So I'm going to take this guy away. And yeah, I think this will work. Yes. Okay, so I think that's good. That's all I wanted to cover. Probably took a little longer than I expected, but that's okay. I'm happy that I was able to demonstrate the dangling else problem. If you would like to read more about the dangling else problem, you can find this article on Wikipedia. And yeah, and my solution to solve the dangling else problem is to not allow it from happening in the first place by requiring users of my programming language to use blocks like that. And if you do that, then you will not have the dangling else problem. I don't know if this solution is what you prefer, but if you can come up with a different way of solving it, then that also works. This article will probably talk about how to resolve this problem, and my guess is most of the programming languages that have to deal with this problem, they resolve it by just picking one of those two, always. So that in the semantics of their language, they always pick one of those interpretations as the correct one, rather than allowing both to be quasi-correct. Okay, I think I've been talking for long enough, so I'm gonna stop this video, and thanks for watching.